Hi there, this is Jacob Nash Algebra Lessons, and this is another Unit 2 lesson on linear programming. Well, that's kind of redundant because that's what this unit is called. But all the things that we've learned so far in this unit, like the absolute value and then like system of equations, graphing inequalities, things like that, they were important to know because you need to use all those things. Well, not necessarily the absolute value, but the other things to do linear programming. So, well, if you're watching this, you'll see that the date was posted in March 2021. And so, yeah, good that we made it to March. I don't know. I like March. I like this day. I made this on March 1st. I don't know if this will be posted on that day or not. But I kind of like that day because I'm not a big fan of like February and January that much. It's like boring, I don't know. I don't really like this months that much. So it's good to be in March because that's when things start to get a little bit warmer. But where I live, it was actually like 84 yesterday or something. So whatever. So what is linear programming? Well, this is when you might think, what's all this stupid stuff that we're learning? Like, how would you even use that? Well, you use that, you can actually use that in real life situations, and linear programming shows that. So, you'll have a word problem, and then you'll have to graph it, and then find out what's the best thing that you could do for that situation. So, for example, if you have a certain problem where it's saying, like, you need to maximize profits, there's different situations that could occur, but there is a way to figure out what's the best situation. So let's look at an example. So I obviously I'm not going to write a whole word problem on here, but you just listen to what I say and I'll write down the numbers as I go. So let's say, well, there is something called All Things Algebra, ATA, and that's a useful resource for algebra, so I suggest you look that up, because they have some good things. So, here's one problem that there is, but I'm going to change the numbers, because I don't feel like doing the same numbers, because I already have that worked out. It says, the smallest plane in a coast-to-coast airlines fleet offers first-class and tourist-class seats. So, it doesn't really matter what the situation is, but you just need to pay attention to numbers, basically. So, this airline thing has a first-class and tourist-class seat, so that's what we know so far. It can hold a maximum of 50 passengers. So, since we just saw a number, let's write that down. It has a maximum of 50 passengers. I'll just abbreviate that. Passengers. In order to charter a flight, the airline must have at least 8 first-class tickets and 20 tourist-class tickets. So 8. I'll just say FCTs. First-class tickets. And it also needs to have at least 20 tourist class tickets. I didn't mean to say seats for the other thing, sorry. So that's what we know. What else? Company makes $40 profit for each first class seat and $30 for each tourist class seat. So we know it's $40 for these ones. Let's just do that. And then it's $30 for these ones. So you just got to make this thing simple. Like, it might seem a little bit hard, but if you just do this, it'll make it simpler. And that it wants to know, what can the company do to maximize its profits? How many tourist class seats and first class? I keep saying seats. First class tickets and tourist class tickets. How much do they do? or how much should they sell of each kind. So, how do we know? How do we know? Well, there's 4 steps to do when we're doing this linear programming. You need to first write the constraints. Okay? So constraints. What are constraints? Well, it's everything I just bullet pointed. But we're not going to leave it in this form. We're going to put it in an equation form. So we have to figure out what we need to make an equation out of these 3 things and see what we can do. So first we have a maximum of 50 passengers. So maximum means that it can't be more than 50, but it can be 50. So that means it has to be less than or equal to 50. Well, okay. So at least we know that. It has to be less than or equal to 50. Well, what? Passengers. But what is passengers? Well, we know that there's going to be a passenger for each ticket that there is. So I forgot to say they made ticket first class tickets X and tourist class tickets Y. Sorry about that. So if we know that there's a ticket for each passenger, then that means that all of the tickets will be less than or equal to 50. Well, we don't know how much tickets there's going to be, so we just have to say X plus Y because those are the 2 possible kinds or variables of tickets that there could be. So we know that X plus Y is less than or equal to 50. So there you go. That's our first constraint. What else? Oh, well, 2 ones that are always there for real life situations is X is greater than or equal to 0 and Y is greater than or equal to 0. Well, why? Let's think about it. Well, in this situation, if all the number of passengers has to be less than or equal to 50, well, we know that there couldn't be a negative number of passengers in real life. There couldn't be -3 passengers or something like that. So we have to set more constraints, which says no, can't make it go below 0 because that's dumb and stupid, and it's not even a thing that there is. So that's why we have to do those. Okay, now what else? We're also given it's at least 8 first class tickets and at least 20 tourist class tickets. So at least means that it can't be less than that, but it can be that. If it said more than, then that would be where it doesn't have a line under it. But we will have a line under it. So it has to be at least 8 tickets. So that means it has to be greater than 8. Greater than 8 tickets. But it could be 8 if they wanted to be all lazy and just say, 8. Fine. But we know that that's X, so we're just going to say X. So there we go. That's what we have. Then we have Y. Y is the 20 or the tourist class tickets, and there has to be at least 20. So that means it can be greater than 20, it can be 20, but it just can't be less than 20. So we have our constraints. That's all we're given. So we have 5 different things here. 1 here, 2 here, 3, 4, 5. And what we need to do is graph these 5 inequalities. So that might sound crazy, but it's really not that bad. We figured out how to do that. So if you don't know how to do that, look at previous lessons in this unit. But before we do that, we're going to need to make an equation. Sorry, that's not even right English. So we have, what is that going to be? Well, this means it's our objective function. That means it's the ideal thing that we're going to do. And whatever x and y is, we're going to plug in to see what the profit would be in certain situations. Which technically you could just go through each possible one, like, 8, 20, 9, 21, or something like that. But graphing it makes you know what's the best thing. So we will they want to have the maximum profit. So let's just say P max, maximum profit, equals what? Well, we were given that, let me highlight this. For each first class ticket, they get $40, and for each tourist class ticket, they get $30, okay? So, that means we can have 40 times x. Ooh, still on highlighter. Thought I was not on that. 40 times x. So it will multiply 40 by how many tickets they do. We know at least it's going to have to be 8. So 40 times 8 is the minimum profit they would get from the first class tickets. And then we'll have 30y plus 30y, because for each tourist class ticket, there's $30. So there we go. That's what our objective function is. So that's what we have right now. Now we need to graph the inequalities. Okay, so let me have my x and y axis. But we know that x and y can't be negative. So there's not going to be any values here, here, or here. This is the only place where they're, in that quadrant, is the only one where there's both positive x and y values. So the first thing we'll graph is x plus y is less than or equal to 50. Okay, well, we can't really graph a line in this form. Oh, you could convert it to y equals mx plus b form. So, well, yeah, let's just do that, actually. So we would subtract x, and then we would get that y is less than or equal to negative x plus 50. So we know that the y-intercept is 50. So let's just say 50 is right here. And we know that the slope is negative x, so that means down one, right one, down one, right one. So it's a negative slope. Well, let's just do yellow, because we did that right there for this line. And we know it's going to be a solid line because of this, that there's a line under the inequality symbol. So it's going to be about like this. Yeah. So, sorry about that. Anyways, we also have, well, that's actually not so good, because we also need to know what the x-intercept is of this line. Y is because, the reason why is, well, we'll need to know the coordinates, and then that's what we plug into here and here to find out what's the best profit. But we don't need to do that right now. There is a way to find that, but that's okay. We just did it this way. There's other ways to do it, but that's the way I did it. So now, all the other 4 equations, this one, this one, this one, and this one, all don't really need to be converted to anything, because they only have one variable. So when it's x is something, when there's only a x, that means it's going to be a vertical line if there's only an x in the inequality or equation, and it's horizontal if it's y. So let's do the, oh wait, that's dumb. I'm sorry. I don't know why I did that yellow, acting like that was the thing to do. So let me actually just see. Can this thing erase? Dumb thing. Okay, I'll just do, I don't know, I guess I'll just do blue for all of them. How about that? Okay, here's that line. Alright, now we have x has to be greater than 0, so that means it's going to be here. We'll do shading in a minute. Well, it doesn't really matter where everything shades, we just need to know at least what direction it's going to be, so we just do a couple little hash marks to know. But there's going to be just one little region where the best profits are. So that's the goal. This will make more sense in a minute if it doesn't right now. So for the first equation we did, we see that it's less than or equal to 50. So that means it's going to be below. Below. So that it's going to be in this direction. And for the one we just did, it has to be greater than or equal to. So we know it's going to be this direction. Okay, we also have y has to be greater than or equal to. I hate this sometimes. Definitely better than some of the things I've used on other Jacob Nash channels, but whatever. Okay. So if it's greater than or equal to, it's going to be this way, okay? So we see a little triangle that's been made, but we still have two other equations that will further make this smaller. So now we have x has to be, we find out that it has to be greater than or equal to 8, so that kind of just contradicts what line we just put on there, but that's okay. So that means that we're going to have 8. We have to have 8 right here. That means that's the x-intercept. So this isn't exact, but it would be maybe right there. And so then we have this line, once again solid. So now, and we know that it's greater than or equal to 8. So that means it's this way. Okay, so that means this region, it's only this region so far. Okay, the last one is y is greater than or equal to 20. So that means it's, that's probably about right here. If this was 20. Ugh, dumb thing. Okay, and it's greater than or equal to 20, so that means it's right here. So that means that the region where they all are, so that's going to be, that would be right here. So let me just do yellow to show you. Come on. Oh, great. Okay, so sorry, that's just how it has to be. I know that's a little bit out of the line, but that's just how it is. Okay, so now we have that region. That means everything that's in that little triangle is going to be the best profits possible. Well, actually, they're the only profits that there could be, because considering all these constraints. But what value in this triangle is going to be the best? So this video is long, I know, but it shouldn't take you this long, because that's just because I'm explaining it. Okay, so let me just close off this. Okay, so the next thing that we need to do, well, also I forgot to say, this is called the feasible region. Feasible. So that's the only thing that there can be. If there was a point right here, that wouldn't work because one of the constraints isn't met. So now, using this equation that we made earlier, that's right here, we need to figure out what's the best possible situation. Well, to first know that, we need to know the coordinates of each of these, the sides of the triangle. So, the coordinates. So, triangle has 3 sides, so that means 3 sets of coordinates. So, we know the one up here is 0, 50, because that was the y-intercept, remember? That's right here. That's what that is. Then the one right here is going to be 0, 20, because that's another y-intercept for that line. And then right here, we don't know. We don't know. So how would you find that? Well, what you would have to do is you would have to plug in a value. So let me see how I can explain this in the best way. Oh, well, actually, we do know that this has a y-coordinate of 8. Hold up a second. I think I did something wrong. Oh, no. I meant 20, not 8. Hold up. Wait. I think I did something wrong. Wrong. Hey, I'm sorry. I think yeah. It's like, yeah, I think it's like shifted over the wrong way or something. Because these three lines are not supposed to connect right here. What did I do? It's just the way I drew it because it's not to scale. That's why. Really, yeah, that's not the region. That's not the region. Let me see if I can try to redraw this. I apologize about that. Okay, let me see if I can fix this. So it's like this. That's the x or y-axis. This is the x-axis. That's there. And then still not the best. So really it's this. This is the region. Okay. So now we know that that's not actually the things that there are, because I messed up. So actually, here's what coordinates we have. We have, for the top one, we know this is 8. So we know, let's write the things we know. We know this is 8 right here. We know this is 20, and then we know this is 50, just from when we graphed it. So we know, we don't know. We know that this is 8, but we don't know the next coordinate. How would we find it? We have to plug in 8 to the equation that is. So that was this equation. Remember, this line is that equation. So we plug it in. Then we have 8 plus y. And even though this is an inequality, when you're doing it for this purpose, you just say equals. Equals 50. So then we would know y is 42. Okay? 42. So we found out that. That's how you do it. Nothing super complicated. Now, what would this point be? Okay? So still 8 for the x. Do we know the y? Yes, luckily we do. It's 20. It's right here. So we have 20. Hopefully your thing would be a little bit better because it's on a graph, but I couldn't do a graph because there's nothing that goes to 50. Then the last thing we need to know is this point. Do we know... We at least know that the y value is going to be 20. But if we know this, that doesn't help us because the equation is... or wait, never mind. Even we can still plug that into this equation. So yeah, sorry. So we have x plus 20 equals 50, and then we would see that x is 30. Even though that's not the equation for that line, because I don't know what I was thinking. It doesn't have to be what line it is. So there you go. That's 30. That's how we found the 3 coordinates. So what do we do with those 3 coordinates? So let me highlight them in green so we see them. So we have 842, we have 820, and we have 3020. Well, for each of those, we're going to plug it into this equation, and whichever one has the highest number when we plug them in is going to be what's the best thing to answer our question. So let's see. Well, we have P. I don't need to write max right now. I just don't feel like it. So we know we're plugging it in 3 times. So let's just write these 3 equations. So there we go. Okay. Now we need to plug in each value. So I'll do the x's in blue so we see. So we have 8, 8, and 30. So I'll just keep it blue since I was doing that. 8, 8, 30. I'll do the Y's in red. 42, 20, 20. Ooh, 20, 20. I don't like that very much. 42, 20, 20. There we go. Okay. Let's plug in those values. And I already know what the answers are. I told you I was going to change the numbers, but I didn't because I forgot. So we would get for the top one, once we plug that in, we get $920. For the second one, we get $1,580. And for the third one, we get $1,800. Oh, dumb thing when scrolled. Okay, and the next one was $1,800, okay? Obviously, we see that 1,800 is the best one. And that was for the bottom one. So we see that this is the best possible situation, which would be for this point right here. Right here. At that point on the graph, it's the best. So remember that this is our X and this is our Y. And so Y was, remember that it was first class tickets, or sorry, X was first class tickets and Y was tourist class tickets. So after we erase all of this, we can finally answer our question. That is, what's the best amount of tickets of each kind to sell for the best profit? We have 30 first class tickets, and then we have 20 tourist class tickets. There you go. That is how you do linear programming. I have no clue how long this video's been, but I'm pretty sure it's been long. So, once again, even though this took me a long time, it should take you a long time because you don't have to explain. You only have to do the work. If you notice, the work didn't take me long. It was the explaining that did, and then messing up. So I apologize for that. But with that, that will be the end of this video. So thank you for watching, and that will be it.